Okay. So this is going to be called, yeah, you should probably take notes. Okay, and this is going to be called line of estimate, line of estimate, okay, for fitting an equation to data, it's all in the book. There's all kinds of different ways that you do it. This is real important for CSAT type stuff. I gotta tell you. So you should know how to do these kinds of things. So what they will do with this is make a scatter plot to represent the data, draw a trend line, and write the equation for the trend line. Use the equation to predict the time needed to travel 32 miles. So what you should first do is make a little graph. And I'm going to take my straight line tool and draw a grid as best as I can, like that. Maybe and like this over here. And I'm going to call this, which one do you think should be on the x-axis? Which one do you think should be on the y-axis? I'm going to graph these points. Times and miles. Miles times, which one do you think should go? What?
Time on the X, and miles on the Y.
Time on the x, miles on the y? Okay, that's not the way they do it in the book.
All right, so do the other one.
Yeah. To tell the truth, it doesn't really matter which way you do it, but I think you guys are right, okay? I think that time should go down here.
That's what they learn in L science.
Time should go down, you're right. Time should go here, and miles should go here. Because the miles kind of depend on the time, right? So that's called the independent variable. That's called the dependent variable. Now I got to think about a scale. Look at the numbers. What do you think would be a reasonable scale to use? How much should I count each one of these boxes by? Look at the time. 27, 46, 71, 107. What do you guys think? 10 or 20, right? 10 or 20? So I think I have 10 boxes. If I have 10 boxes, I should be good to count by 10, okay? So let's count this as 10, 20, okay? 20, 30, 40, 50, 60, 70, 80, 90, so there's my 100 mark. Okay? And what do you think would be a good scale to count on going this way? What do you guys think? Maybe by 5? Maybe even by, since I'm only going up to 22, could I count by 2s? How many boxes would I need to count by 2s? I need 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have it, right?
So what would you
So,
do? What would you want on the time?
what? I went 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, right? Each box counts as 10. I'm going to just to spread it out. So this is part of the problem, is figuring out what kind of scale to use, right? And that's kind of what you guys need to do as well. So this would be 2, 4, I'm going to count each box as 2 miles. 6, 8, 10, yes, Tony?
Instead of going by 2, can you also go by 5?
We could go by 5, but then it'd be kind of squished, you know? You could, but I kind of like, you know, it depends. It's up to you, okay? But I think I'd like to kind of spread it out as much as I can. All right, so 10, 12, 14, 16, 18, here's my 20. All right, so this would be 22 up there. So then I plot these points. This is kind of fun to do. So I'm going to take a different color, red. Let's take red. I'm going to plot the point 5, 27, 5, right? So 27, 10, 20. We're counting by 10s, right? So 30, so a little bit short of 30, and up 5. 2, 4, 5, so a point about there. Questions? Good? So far? Then I'm going to take this point. 46, 10. So this would be 40, so where would 46 be? In between 40 and 50, right? And go up to 10. So somewhere, and it doesn't have to be exact, but about there, because that'd be 45, 10 would be right smack in the middle. Then I'm going to go to 7114. So 50, 60, 71, just a tiny bit past that line. Now 14, 10, 12, 14, so maybe about there. Does it look like it's starting to make a line? Huh? Yeah. Okay. 78, 18. So let's see, that's 80. So just short of 80 and up to 18. So that's 14, 16, 18. So maybe about there. And then 107.22. So here's 110. So just short of 110 and up, way up to 22 up there. So maybe about there. All right, so it says make a scatter plot. We did that to represent the data. Draw a trend line and write an equation for the trend line. Use the equation to predict the time needed to travel 32 miles on a bicycle. This is a classic, perfect CSAT problem, isn't it? Okay? They would ask you to do this on the CSAT definitely. They would ask you to label your axes. They'd ask you to make a scatter plot, and then they'd ask you to make your line of best fit.
And also ask your title.
Title it, yes they would. And they'd ask you to keep your units. Well, this is miles, right? You would probably have to have distance over here. Distance in miles. And this would be have to be time in seconds or minutes? Minutes. And you would have to put the units down there. So then what you want to do is what they call a line of best fit, or a trend line, which they call in your book. And what you want to do is figure out a line that will hit, not the line that hits the most points,
It goes
but
through the middle.
kind of through the middle. It's kind of like taking the average of all those points. And the other thing to know is it doesn't have to go through 0, 0. Okay? It won't always go through 0, 0. So what I'm going to do is I'm going to start about here. Okay? My tool is kind of cool because I can kind of adjust it as I go. But would you say this kind of is a pretty good trend line? You guys? Like that? How does that look? Good? Okay. And you should do that with a straight edge or a ruler. Okay? So go ahead on your paper, go ahead and do that now. Make a nice straight line to the best of your ability. Good? Make a nice straight line that goes through many of those points. Now, to come up with an equation, what I need to do is, they're going to ask you, well, they want you to do it in point slope form. So what you're going to do is y minus y1 equals m times x minus x1. And what you want to look for is a point that this line seems to go through. Does anyone see a good point that this one exactly hits where it crosses somewhere? Anyone see one on here? Where's the nice? See this one right here? See how it's right on the crosshairs? See that? That would be a good point to choose for your point that you're going to plug into point slope one. Okay?
I think it's a 1-to-1 line.
Wait, what are you doing?
So I'm looking for a point that is on the line. And I'm looking for a place where it's right on the crosshair, so right at the middle of
Go up 2.
Go up to, yeah, you're pretty close, but it kind of falls offset. See how it's not exactly right there? Okay. So I'm going to take this point. What's this point? What's that point according to my scale? Now what's this?
It's 90.
90, 18, yeah. 90, 90, comma, 18. And then the next thing that I need is the slope. So to figure out the slope, what you want to do is kind of, and what Fred said is kind of right, you want to make a little triangle, and you want to figure out, go from one point on the line to another point on the line, kind of like that. Yeah? Yes? Yeah? And you could have gone like this and like this, as long as it hits the line twice. And it's not going to, these answers are not going to be exact. How much did I go over from here to here? 2 boxes, which is how much as far as time. 2 boxes is how much time? 20, right? And then I've gone up 2 boxes, which is how much? 4, right? So my slope is not 20 over 4. Rise over run. What's my run? 20 is my run. 4 is my rise. I could reduce that to what? 1 over 5, right? So now I have a slope. I have a point. I can plug those into my equation. So I'm going to go y minus y1, 18, equals 1 over 5 x, should be actually be t, but that's okay, x minus, right here, 18, x minus 90, okay? See that? Okay. Now, so what you end up getting is this, and then they're going to ask you, use the equation to predict the time needed to travel 32 miles. Okay? So using this equation, I'm going to take 32, and I'm going to plug it in, which is miles, x or y? Which is miles, x or y? Y. So what that's asking you to do is to take the equation that you have and take that number and put it in there for y. And if so if I do that, I get 32 minus 18 equals 1/5 x minus 90. And they're asking you to solve this for x, okay? Figure out what the time is when y is it. 32 minus 18, what's that, Tony? What's 32 minus 18?
That is...
I think I knew. 14, very good. 14 equals 1 over 5 x minus 90. Now, to get rid of this 1/5, what could I do? What could I do to get rid of that 1/5? Anyone? Multiply by something.
Oh, times 1/5 everything.
I'm going to times by 5, not 1/5. Times by 5, which is going to make this disappear. Okay? 5 times 14, I think, is 70. And I get 70 equals x minus 90, right? And then what do I do? And what do I do?
That's 90.
Add 90 to both sides. Plus 90 plus 90. And I get x equals 90 plus 70, which is 160. So that's how many minutes it would take you to go 32 miles, according to your graph. Okay? It's a little long process. Okay, for that reason, I didn't give you all that many homework problems.
I don't look at the board.
No, that's not your homework on the board. Your homework is page 320, 1 through 5. Let's just do this. And it says to use a graphing calculator. We're not going to use a graphing calculator. Page 320, 1 through 5, which they actually have the graphs for you. You don't have to graph it. 1 through 5, they have the graphs for you. And all you have to do is find the trend line, okay? Then for 7 and 10, you have to go through that process that I just did. So you have to plot the points, come up with a graph, and see if you can come up with a trend, okay? All right, so give that a shot. Sorry, rushing, but got it.
How much time do we have? We have, thank you, 1 minute. 30 seconds. Wonderful. That's